Hi, I'm the Mossman. And in today's video, well, the weather's getting nicer, it's heating up, the sun's coming out, a little slower where I live, but it's coming. And so that means it's time for a little bit of maintenance on the plants that I'm keeping inside, as well as all the plants outside, but these aren't mine. So today we're going to be doing a little bit of spring cleaning. And at the end of the video, I have a little project that I did for one of my courses. It's a fun little video. It's basically a summary of a paper in visual. That's okay. I'm sure you'll like it. Anyways, let's get cleaning. All right, so the first thing we're doing is taking all the ferns that I have. They're kind of dead because in the winter my room gets below 10 degrees Celsius and the light is lower, so a lot of the leaves kind of die off, but fortunately the rhizomes and the roots are all still healthy. So once we take away all the dead stuff, the fresh green fronds will come through. And now I'm not cutting it down too hard. I'm leaving like an inch or two when I'm cutting, but yep, that's the gist of this. With this rabbit's foot fern, I'm also cutting off a few stem rhizome material chunks here and there. It's probably best not to do a lot of this because this results in some pretty heavy water losses, but it's pretty dense and I like to thin it out. And of course we give everything a shower because I've got a lot of plants to water at once. So I'm repotting this Philodendron Birkin. It's probably not the only plant that needs to be repotted. And then you can see I'm using the pot in a pot method with the decorative pot on the outside, which also acts as a tray to catch water, with an interior pot which allows for drainage still. Now I'm adding soil mix of like a tropical mix basically, and then some pine bark and some wetted sphagnum that I have lying around just to create this like basic tropical mix with more aeration. Now it also needs support, so I've added a couple chunks of bamboo and the wire that was already there, moved things around, tied things up, and yeah. Now the final thing that I need to clean up is this entire corner. I've got a lot of junk here, so we're gonna pull it all out, organize it, clean the floor of course, and then throw everything back in. Random boxes and Now, getting rid of things doesn't mean necessarily throwing away, like this Lego set and this. I'm not sure if this works, but this would go to electronics recycling, I guess. This will go to somebody, probably. This, I have no idea what this is. I know what that is, though. Okay. Tea leaves in rum. But I have no idea how long that's been sitting. This can obviously all be recycled. This can be recycled. This, I can reuse these for something. And then these will just go in plant storage. Got some sphagnum, pumice, reindeer moss, which is actually a lichen, some perlite, so much charcoal. I don't know what I ever needed this much charcoal for. A little bit of fir bark. I guess I also have this container, sphagnum moss and stuff that I found around. That stuff's still, well, it's still green. Next, we have this perlite. And then we have these odds and ends. There we go, that's our amendments. Nice and tidy, filling up the center there. Preamble for my video abstract. It's a school project. It's basically practice for research, so the results aren't supposed to be particularly interesting, but I still hope it's enjoyable. Humans and the environment have an effect on the behavior of squirrels. So our group chose to investigate these factors using abundance and location data from camera traps placed in Aldergrove Regional Park. The impact of human expansion and removal of habitats could potentially exacerbate these effects. So what is the influence of environmental and anthropogenic features on Sciuridae family site use in Aldergrove Regional Park? The first step was data collection. Camera traps were distributed around the Peppenbrook Trail at Aldergrove Park and positioned level at knee height. Traps were facing into areas with enough clearance to capture small and large animals, meaning no large trees or understory blocking the line of sight. At the time of camera placement, coordinates were recorded, and then the cameras collected data for around a month. Considering the human impact and understanding what data we would have available, 3 hypotheses were formed. 1. Traffic noise and vibrations generated by vehicles on roads are a perceived threat to squirrels, thereby reducing squirrel activity near roads. With that hypothesis, we could predict that sites close to the road will have less squirrel captures and vice versa. Let's take a look at the actual data collected. Students from each group sorted their photos, any animals were ID'd, and ones that showed up multiple times within 30 minutes were considered the same individual. Multiple animals in the same photo each counted as unique individuals. With counts collected, we began to test our hypothesis. First, any animals that weren't squirrels were filtered out. Each site's distance from the road could be calculated using their coordinates, then a linear regression could be run on this relationship. As you can see, the relationship is negative as predicted, but it's not statistically significant. So let's look at the next hypothesis. In this case, we want to investigate interactions with the environment. We can predict that camera trap sites with higher percentage canopy and larger tree diameter at breast height, or DBH values, will have more squirrel captures. Using the same data per site and comparing it to the percent canopy and mean DBH collected for each of those sites gives us this relationship. We can see that both relationships are positive as expected, However, once again, neither are statistically significant. So the last one required a slightly different technique. 3. We can predict sites further from the trail will have more captures during high human activity. We don't expect this relationship during low human activity. This required data to be divided into high and low human activity categories. So for every site, the number of captures was divided. They were determined based on time when the park is open and compared to Google Crowd data, where it was decided on average human activity is highest between 9 a.m. and 4 p.m. in that area. Other times were considered low human activity. Each category was compared to distance from trail in a way similar to the first analysis using the location data. The chart shows a negative relationship for both. This is the opposite of what we expect, and both show a similar slope, which again is the opposite of what we expect. Unfortunately, despite having the most significance out of all of our data, this is still not statistically significant. What does this mean? Well, it means in all cases the relationships in our data were not statistically significant. Considering the background research, why does our data not align or not support our hypothesis? Findings may align with Kittendorf and Dancer, who noted squirrels have adapted to human presence through tolerance and anti-predator behaviors, making human activity less of a deterrent. Kenta et al. Found these behaviors in squirrels vary greatly by country, altitude, and latitude. Ecologically, our results underscore the adaptability of squirrels in urban environments. This contrasts with studies in less disturbed habitats, where human presence has a more direct impact. Future research could explore larger, diverse sites and consider additional factors like food, resources, and predator densities. Ultimately, our study contributes to understanding wildlife behavior in urban systems and the complexity of human-wildlife interactions, which is essential for effective urban conservation strategies. Thank you for watching. I'd like to thank Dylan, Elijah, and Jonas Meets the Rhythm section for the music that you've been listening to. I also thank my teachers and classmates who let me put that little section at the end up. Yeah, make sure to like and subscribe, and I'll see you in the next one.